All right, we'll go through these story problems that deal with ratios, proportions. First one says 380 cubic centimeter sample of titanium has a mass of 1710 grams. Find the weight of a titanium sample that has a volume of 532 cubic centimeters. Right, and then solve the proportion to find the answer. Basically what we're seeing here is that this gives me a ratio. For every 380 cubic centimeters, all right, that's cc's, I am going to have a mass of 1,710 grams. They then want to know, how does that, because I'm using the exact same substance, the exact same titanium, it should have the same ratio of 1 cubic centimeter per however many grams. So what I'm going to do is I'm going to say 532 cubic centimeters are how many grams? So the X grams. Now, a lot of times you don't maybe deal with the algebra here to solve with units. And I'm going to multiply the units here just to kind of prove a point to you. When I cross multiply, I get 380 times X. It would be, cc's times grams. Equal then, okay, cross multiply, I have, so 1710, let me calculate real quick. 1710 times 532 is going to give me 904,932. Now that was grams times cubic centimeters again. Okay. Now when I'm solving for X, okay, I'm trying to figure out, it says find the weight. So I should have an answer that's left in grams. So what I'm going to do is I'm going to divide the X, divide both sides by 380 cc's. That'll cancel. That cc's will be left over. X grams is equal to, now come over here, and I'll divide by 380 cc's. The cc's cancel out. And I would be left with, so that number divided by 380 gives me 2381.4 grams. Okay, so that's kind of the idea of being left with the right unit. Sometimes maybe some people don't even put this there, and then we cross so it would not be here. And divide by 380 cc's, all I'm left with is just an X. But it was, with grams here and grams there, when I divide out, I get that gram. Sometimes having the G over here kind of confuses people. But if you do it that way, you're left with that grams. Now, a lot of times you don't maybe deal with it a lot in regards to the algebra with the units, but that's kind of we call it dimensional analysis that's occurring there. So the Big Town football team outscored opponents 5-2 last season. So 5-2. It says if their opponent scored 38 points, how many points did Big Town score? Okay, so big outscored means they scored more. So the top is Big Town. The bottom is opponents. Okay, so they went 5-2. Now the opponent scored 38 points. So the opponent should be on the bottom. That should be Big Town score. If I cross multiply, I get 2x equals 5 times 38. X would then divide both sides by 2. 38 divided by 2 is 19. 19 times 5 is 95. Okay, so they should have scored 95 points. And if I take 95 divided by 38, okay, 5 divided by 2 is 2.5. So I should be able to get 95 divided by 38. So it gives me 2.5. So that's kind of the way of checking to confirm that they do have a 5-2 ratio. In the local co-ed softball league, the male to female ratio is 6-6. If there are 160 players in the league, how many are female? Okay. So this one's kind of worded weird. If I go male in my proportions. Okay, that's going to be 6/6 equals. Now I need to go. So let's say this was my males, this was my females. Neither of those are going to allow me to address this 160 real easily. Okay, what I would do in this one is, if there are male and female, I have the ability of saying female compared to total population. So when they give me 6/6, that means that there's 6 females for every 12 people. 6 females for every 12 people. So how many females are there out of 160 people? Okay, we cross multiply, we get 12x times 160. Obviously, you can do some reducing there. 6 times 160 is 960. Divide that by 12, and we get x to be 80. Okay, that should make sense. I mean, there's other ways of doing this problem. 6/6 is a 1-to-1 relationship, and if I've got 160 total people, that should be 80/80. Should be 80 males, 80 females. But this is a way of addressing questions in which the problem doesn't directly maybe target the initial ratio that's provided here. You might see that as we move on some other questions. I think there's a wins and loss question in Math Excel that does that. In a certain desert environment, there are a lot of small rodents. There also happen to be a lot of snakes that feed on the rodents. The ratio of rodents to rodent-eating snakes is 13:3. So 13 to every 3 snakes. So if there are 4,000 snakes, so I like to keep, the snakes are both in the denominator. How many rodents are there? So then we have 3x equals 13 times 4,000. X is going to be 13 times 4,000 divided by 3. There's not a common factor here, so it's going to be x is 17333.3 repeating. And that would be how many rodents I have, and you just round that. So you want around 17,334, that's fine. Currency in Western Samoa is the tala. The exchange rate is approximately 70 cents to 1 tala, so 70 cents. Okay, to 1 tala. At this rate, how many dollars would you get if you exchanged 13.3 tala? So how many dollars am I getting back? So I cross multiply. 13.3 times 0.7 is equal to, multiplying here, which is give me x. So 13.3 times 0.7, I would get $9.31 back. If you can buy 1 plantain for 49 cents, plantain, just kind of like a banana. So 1 plantain